Since the beginning of this video series, we have discovered that all cast actions were conversions, but some of these conversions had interesting properties. More particularly, there is a case of identity conversions, which we call reinterpretations. We also learned a particular case of reinterpretation with type qualifiers. Then we learned that C++ introduced some other types of behaviors, namely upcasts and downcasts, which are cases particular types of reinterpretation, but in the context of class inheritance tree. In sum, there are 5 possible cast actions, namely conversions, reinterpretations, type qualifier changes, downcasts, and upcasts. These 5 types of cast operations will have for C++ equivalent. What are the different cast operators put at our disposal by the language? There are a certain number, and we'll walk through them in all these videos. And in this first video, we'll discover a new C++ cast, which is probably the most visual one, the static cast. The static cast will allow us to make a certain number of conversions, the simplest possible, but also walk through the inheritance tree. Let's see together our first example about conversion on simple values. In practice, the static cast will be written as follows. We'll use a new keyword, static_cast, followed by a strange syntax between chevrons, followed by a parameter in brackets. This syntax will read as follows. I want to make a static cast of the b expression to the int type. Whatever the value of b, here it's a double. I want a static cast, convert this b variable of the double type into the int type. Let's look at the whole example. As you can see, it's very simple, and it'll make you think of previous videos. Here I have a reference value, an a integer initialized to the value 42. Then I want to initialize a b double to this a value. Here we have an implicit promotion, so no problem, it works. We saw that we could make an implicit demotion, but it caused problems and it was advised to use a particular compilation flag. You can see all this in the previous video. The right behavior in C++ is of course not using the C-cast, since this is C++, but using the static cast instead, which would have the same effect in this context. Here we have an explicit demotion of our b variable to a d integer with all the precision loss it can cause. Therefore, we're using the static cast here. It's very simple. I won't spend too much time on this. I just want to show you that from now on, you will use the C++ cast called static cast to convert simple values. Much more interesting now, we'll focus on the usage of the static cast in the context of upcast and downcast. So I wrote the following example, which is pretty close to what we had in the previous video, as I was introducing the notions of upcast and downcast. Here we have the same class hierarchy, meaning that the parent base class and our child 1 and child 2 classes, both inheriting from our parent class. Therefore, we have a vertical hierarchy, parent being more generic than the child 1 and child 2 types, which are more accurate. To make things more interesting, I also added a class I named Unrelated. And you can tell by its name and its declaration that it isn't remotely related to the child 1 and child 2 parent classes. Therefore, Unrelated is a kind of single-noded inheritance tree, completely detached from the inheritance tree of these 3 classes. From there, let's focus on the example. We keep the usual context. We have a reference value, which will be an a variable of the child 1 class. And I can initialize a b variable of the parent address type, using the address of my a instance. Then we learned that it was possible to make an implicit downcast. That's still true. But in C++, when you want to make this downcast in an explicit way, you have to use the static cast, with the same syntax as in the previous example code. meaning the static cast keyword followed by the name of the type you want to cast to between chevrons, followed by the expression you want to cast in brackets. This example shows us that I want to static cast my B variable, so an address on parent, hiding as an actual type an address on child 1, to an address on child 2. We'll see that since this static cast is explicit, it will work. This can be a problem too, and we'll see that C++ has a cast. As we'll see in the next video, allowing to check for this behavior and avoid it. However, the static cast brings the same advantage as in the case of the cast of one class into another, meaning that it will be able to detect when we want to make a cast between addresses not belonging to the same inheritance tree. Let me take the example with my unrelated type. I have the address of my A instance, therefore an address of child 1, which I'll want to static cast to an unrelated, an address to my unrelated class. This line won't compile. Thanks to the static cast, we can be sure that this cast will be made between compatible addresses in the same inheritance tree. Therefore, we do have a vertical hierarchy between classes. We want to static cast, but in this example, unrelated is in a horizontal relation, which means that it isn't related to child 1, child 2, and parent. This line won't compile. To make sure of that, here's a little example. So we'll compile this example. First, we can see that the implicit downcast still doesn't work, of course. This is still C++. But this time, the compiler adds a very interesting error message, saying that the conversion, however explicit, of our child 1 address to an unrelated address is impossible. The static cast protects us and stops the compilation. To sum up, the static cast will allow us to make simple conversions between direct values. It's the most simple and most visual cast in this context, but it will also allow us to make upcasts and downcasts on a hierarchy of classes we are familiar with and prevent casts between unrelated class hierarchies. I'll see you in a moment for the next part of the introduction of the C++ cast. 7:45. See you.